Hello friends, welcome back to our channel. So today we'll see one more session in computer networks, that is a real-time transport protocol. So in our previous session we have seen what is a UDP protocol, and then we have seen the remote procedure call, and now we'll see the real-time transport protocol. The main use of this real-time transport protocol is to deliver the audio and video content through the network. So let's start the session. Real-time transport protocol. So similar to our UDP protocol, so this is represented with the RTP, real-time transport protocol. So main goal is to deliver multimedia content over a network. So here the multimedia means the two things. One is video content, another one is a audio content. So mainly this protocol is to deliver the audio and video content. So if you are giving some audio or video content, if you are delivering the video or audio content, compulsory that should be fast delivery. The packets should be fast delivered, and also low delay. So these two are most important, right? So the application where we are going to use this RTP is simple. So video streaming. Okay. So video streaming in the sense you can see Zoom meetings or WebEx meetings, etc., etc. Okay, online meetings. That's nothing but our video streaming will be done. So that there the protocol used is a real-time transport protocol. Now what are the functions? What are the functions of RTP, real-time transport protocol? Okay, so the first function is sequence number. See, before going to the functions, if you see this fast delivery and low delay, so previous protocol which we have used is a UDP protocol. So we have discussed about this UDP protocol, that is mainly for fast delivery, and also it doesn't guarantee that packet is delivered. So if the packets are lost, that doesn't impact on the application. So here also the same thing, but there will be a slight difference among this UDP and the RTP protocols. So let us see. First one is a sequence number, which is not included in the UDP, but it will be included in the RTP. So sequence number is to identify lost packets. So if there are any loss, if there are any packets lost in the transmission, that can be identified by using the sequence numbers. And also reordering. So the data may be sent in a different order and they may be received in different order. So based upon the sequence number, they will be reordered so that they will identify which packet has been lost during the transmission. So that is the first function of RTP, so which is not available in UDP. And the next one is a timestamp. So here timestamp means it will be used for making a synchronization. So the packets should be delivered at an equal interval of time, or so synchronization, mainly it is for synchronization. So what is this synchronization? So example, if you are getting some video file, so there will be both video and audio. So there should be the synchronization between a video content and audio content, so that the data will not be mismatched. So if there is no synchronization, so the video will be lagging when compared to the audio, or audio will be lagging when compared to the video. There should be perfect synchronization between audio and video. So for that purpose we are going to use this timestamp. And the next one is a payload type. Payload type. So what is meant by payload? Payload means some data. So payload is a data which we are transmitted from one system to another system. So here the type of payload will be either audio or video, audio content or video content. Okay, so these are the three main functionalities of RTP, and all these three are not available in the UDP. So particularly these two, sequence number and the timestamp. Okay, but in RTP, real time transport protocol, we will be having this sequence number and timestamp. So if there are any packet lost, the receiver will be knowing which packets has been lost. Okay, yes. Now how the RTP packet will be represented? So RTP packet will be represented with RTP header. That's a common. We have seen this kind of thing in previous classes. RTP header must be there, and then payload. The payload can be either audio or a video. So this is the packet. Okay. Now what is this RTP header? What are the different fields available in the RTP header? So in our last class we have seen the header of UDP and in header of IP also, IP protocol also. Similarly, RTP header will be having different fields. Okay, so we'll see those fields. The first one is a version. First I'll write here, then we'll see. The first one is a version. So version means it gives the version of RTP protocol. So it gives version of RTP protocol, and the size of to represent this version is 1 bit. Next, padding. Padding means sometimes the data will be transferred in a blocks. So for every block there will be a fixed size. If the data is not equal to the length of the block, some dummy bits will be added. Mainly this kind of padding will be done in the encryption algorithms. Okay, so we will be padding some extra bits, dummy bits, to make that length of the content equal to the block size. So that type of padding. So adding dummy bits. So it represents whether it was added or not. Okay, dummy bits. Size is again 1 bit, and I think this is a 2 bits. Okay, padding. Next, extension. So some header formats will be having some extensions, right? So such type of extension, is it available? So we have seen this extension in IP header also. So whether it is having some extension or not. So it is also the size to represent this one is a 1 bit. Next, CSR count means contributors count. What we are saying means contributors count. So here what is meant by contributor? So we are giving an example of video conferencing. So video conferencing. Okay, so in this video conferencing, this will be the source, and so this is the target audience, user 1, user 2, user 3, user 4, and so on, right? So here the contributors count means at a time all the users can communicate with the source. So these particular contributors, that means at a time how many of the users are being active, inactive, right? So that is a contributors count. So the size to represent this contributors count is 4 bits. So you can imagine here we are saying it as a 4 bits means the total number of combinations will be 15. That means 0 0 0 0 to 1 1 1 1. So this is 0 and this is a 15. So total 15. So at a time only 15 contributor count can be represented. Okay. Next, marker. Marker means in order to represent important events, whether there are any important events, that means high priority events, so that will be represented with a marker. So size is here 1 bit. So how it can be represented, you can see, you can observe here adding dummy bits. So that means here it is represented with only 1 bit. That means if this particular padding bit is 1, that implies padding exist. That means there is some padding. If padding bit is 0, that implies no padding. There are no dummy bits. So in such a way, this will be represented. And here also the same thing. Extension. If the extension bit is 0, there is no extension. If the extension bit is 1, there is an extension. So similarly, contributors count, that can be, the maximum count can be 15. It can be from 0 to 15. And here also marker representing the important events, priority. So for which kind of data the priority should be given. If there are any prioritized events, then it can be represented with a 1, otherwise it will be represented as 0. So next, marker, and the next one is payload type. Just now we have seen payload type means whether it is sending audio or video, and the size here it represents as 7 bits to represent the payload type. Okay, and then sequence number in order to rearrange the packets at the receiver side, reordering, and also identify the packet loss. So the size to represent this one is 16 bits. 16 bits. And the next one, timestamp. This also we have seen just now. So in order to synchronize the audio and video, okay, so this timestamp will be there, and the size is representing is 32 bit. And the next one is SSRC. So that means source identifier. Okay, yes, identifier. This is a source identifier. Okay, source. That means source ID. From how many sources the video or audio is coming, right? Similarly, CSCR. Sorry, CSRC. SSRC, source RC. This is a contributors identifier. Contributors identifier. That means we have seen, so these are all at a time how many users are interacting. So that is a contributor. So source identifier and the contributors identifier. So all these are in a RTP header. So version, padding, extensions, contributors count, marker, payload type, sequence number, timestamp, source identifier, and contributors identifier. So we'll arrange all these things in this RTP header. Hope you understood this one. So everything will be represented in a 32-bit word. Okay, 32-bit word. So let us represent this one. So version, next padding, extension, contributors count, payload type, and sequence number. So here 1 bit, sorry, 2 bits, 2 bits, 1 bit, 1 bit, 4 bits, 7 and 16. Yes. Okay. And then here it is a timestamp. One more bit is here, that is a marker. This is one, right? Now it was done because 2 plus 1 3, 3 plus 1 4, 4 plus 4 8, 9, 16 and 32. Total it should be 32. So this is a 32 bit word. So every header formats will be in a 32 bit words. Okay, so timestamp, and it is also 16 bit, sorry, 32 bit. And then source identifier, this is also 32 bit. And contributors identifier, and this is also 32 bit. So this is the header, and here the payload will be either audio or video. That will be this one, and total this will be calling as a RTP packet, real-time protocol packet. Okay, so the difference among this RTP and UDP means, so in UDP we are not having the sequence number, particularly the sequence number and the timestamp. It cannot detect the errors. But here in the RTP, real-time transport protocol, it will identify the lost packets. So whatever the packets has been lost, so that will be identified by using the sequence number. And also here we are delivering the audio and video, so there should be a synchronization between the audio and video. For that purpose we are using this timestamp. Okay, so hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.